Now let's look at compound types. Here there is two compound types, tuples and arrays. Tuples are fixed in size. As you can see here size is 3, and it has mixed types. We have I32, F64, and Boolean. You can access tuple element with dot and the number of the index of the element. Like if you want to access the first one here, the I32, then tab.0 will access the first one. Tab.1 will access the second one, and tab.2 will access the third element. And here at the bottom we have an empty tuple, and we mentioned this in the first module, the unit, which is an empty tuple, and it returns nothing. So let's now print out each element. So we're going to print out the first element, and here the first element is tab.0, and to print it we're just going to type first here, and let's just run. And yes, 500, because the one that is here, the first, the tab.0 will go on the very first tuple, very first index, which is 500. That's its value. You can also access the second one and the third index as well. Now let's move on to arrays. Let's remove this. And then uncomment. So here we're creating an array of 5 values, and these are the values in the arrays: 1, 2, 3, 4, 5, and it's of type I32. This shorthand here create an array of 10 zeros. And crucially, Rust only checks array bounds at runtime. R10, so R of length 10 on a 5 element array panics. No silent buffer overflows like in C. So let's run our code. So here we're going to go in that array. So our array has 5 elements, and for n in array we're just going to print the element in the array. So let's run it, cargo run, and we see here we print 1, 2, 3, 4, 5 as we expected. We see this 1 and 5 comes from here because we printed out the first index, the 0th index, and we also print out the length of the array, which is 5. Pro tip: arrays are stack allocated and fixed size. Use vec when you need a growable list. Now let's see the comparison between array versus vec. Arrays are fixed size, stack allocated, extremely fast. The size n must always be known at compile time. Use when you know exactly how many elements you have. Vectors, on the other hand, is growable, heap allocated, dynamic size. Can add and remove elements at runtime. This is your go-to for list of unknown length. Rule of thumb: arrays for small fixed size data, use vec when the number of elements isn't known at compile time. Now let's look at custom types. Structs lets you group related data under a single meaningful name. Group related data, name types. Instead of passing 5 separate variables into a function, you bundle them into a struct. One name, one concept. Field shorthand, concise initialization. When the variable you are assigning from has the same name as the field, you can write user as here, user, username, and email instead of username, email. Let me illustrate it to you so it makes sense. So we have this struct and we want to call a variable that will initialize it, all different field. So here we're going to let user equal, and then we get our struct and we say let's mute user, and here we're gonna have our struct username. We could do this username if our parameter had username, we had username on our parameter, we could do that. And we have email So this is one way of doing that, but we don't have to. We can simply do this. We just leave it like that. Username and email. So it's a minor convenience that keeps your code clean. We also have a derive attribute. This attribute auto-generates implementations of common trait. We have debug that lets you print the struct, and we also have clone that lets you copy it. We also have partial EQ that you use to compare two instances with double equal. You get all that for free with one line. Let me show you how you do that. On top of our struct, we do the following. Derive debug, so this will help us debug. We also have partial EQ that will help us comparing two different instances with equal, double equal. We also have clone that will allow us to copy our instance. Okay, in short, a struct definition is just a name and a list of name field with their types. Here's a real-world struct that's relevant to blockchain development. Notice total supply is I-28 because token supplies on a blockchain can be enormous and we want overflow protection. Notice also the underscores in the 50 billion. Rust lets you use underscores as visual separators in numeric literals, just like commas in written numbers. So they're ignored by the compiler but make large numbers readable. We also have string create from, which creates an own string from a string literal. We'll go deeper on the difference between string and string slice in ownership module. Let's look at this code. Structs can have behavior attached to them through implementation, IMPL. Two kinds of functions live in the implementation blocks. Associated functions don't take self. They call on the type itself. This is the standard pattern for constructors in Rust. The return type self is an alias for the type being implemented. Here it means rectangle. Methods take self as their first parameters. Self, if an operand, is a read-only borrow. The method can read but not modify. Mute self, as in here, is a mutable borrow. The method can modify the structs field. And pro tip, associated functions like new don't take self. Methods borrow self as self or mute self.